So a lot of you have been wondering about Lewis structures, and in particular the ones that I put on the practice problems on Moodle. So I thought I'd review them really briefly here just to remind us that really we just need to follow the same rules we've always seen for these. So the first one is TeF5 minus. So this is tellurium pentafluoride, 5 fluorine atoms around a tellurium. So first step, we're going to look for our central atom. Again, we're going to go with the first atom listed, not only because it's the first atom listed, but I've got 5 fluorines listed again next to tellurium, so it would be odd for one of those fluorines to be the central atom. So if I think about a central atom and I think about bonding 5 fluorines to that central atom, I would just start with this structure. So I'm just at least going to start with this network here. And one of the things we tend to do with Lewis structures is if and only if my species is charged. Usually I'll indicate that by putting it in square brackets and then putting the little minus sign up there, or it might be a -2 or -3 or whatever it is, just to remind me that this is a charged thing. So if I'm tallying up all the electrons I need to worry about, I count valence electrons for each species, each atom in this thing. I know tellurium carries with it 6 valence electrons. It's like oxygen. Fluorine, we've seen this many times before. We count in the periodic table from the left to the right until we get to fluorine. We see that it comes with 7 valence electrons, and we've got 5 of those fluorine atoms. So that's going to give us a total of 35 electrons coming from fluorine. And finally, we know that it's a negatively charged thing, so we're going to add an extra one. And so if I add all of this up, I should get 42 electrons. So I've got 42 electrons I need to worry about and need to place in this diagram. If I look at what I've got already I've got 1, 2, 3, 4, 5 bonds. Each of those has 2 electrons, so that means that I've already got 10 electrons in my system. And so I've got 32 electrons left to place somewhere in this diagram. So according to the rules, the next thing I should do is fill octets around all of my outside atoms. So if I do that, I'll get the following. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, can't really see those very well, 25, 26, 27, 28, 29, 30. So there's 30 electrons that I've just placed into that diagram by filling all the octets on my fluorines, and I notice that I've actually still got 2 left. So the 2 that I've got left, according to the rules, again, we'll just put right on the central atom. And so if I put my 2 electrons there, I can see that this is likely what my Lewis structure would look like. The question probably also says to indicate formal charge. So to indicate formal charge on what my atoms are, and it's always a good idea to do formal charge even if the question doesn't ask you to do formal charge, what I do is I ask myself, how many valence electrons do each atom bring in with it, and how many electrons does it have right now? And so the first of those 2 questions we've already answered. So with tellurium, we know that it came in with 6 electrons. That's the valence for tellurium. And if I look at what it has now, it's got 1, 2, 3, 4, 5 bonds and a lone pair. So if it gets 1 electron for each of those bonds, that's 5, plus the 2 in the lone pair, that's a total of 7. We know it came in with 6, now it has 7. The difference between those is -1. So the formal charge on my tellurium atom here is -1. If I look at the fluorines, I know the fluorines came in with 7 electrons, and if I count what is around the fluorines, I've got 2 there, 2 there, 2 there, for a total of 6, plus 1 in the bond, that's 7. So fluorine came in with 7, it now has 7, so its formal charge is balanced at 0. Every one of them is exactly the same. I don't have to do it separately for all of them. Sorry for the ugliness of my zeros there, but the point is that I do have a lot of zeros in this structure. Now you might be worried about the fact that I've got a -1 left over because I said in class we'd like to get zeros. But don't be worried too much because this is actually a negatively charged thing. And negatively charged things, in fact, whatever your charge is, whether it be 0, -1, +1, whatever, the sum of all of your formal charges must equal the total actual charge on your molecule. So we know before we even start that one of these is going to be -1. And so if it's the tellurium, that's fine. The structure that I have right now is certainly a plausible Lewis structure for this species. And although it's not on the test, you can look at this and say, oh, interesting, there's 6 electron domains around tellurium. That's going to have an octahedral geometry. I know one of them is a lone pair, so this is probably going to be a square pyramidal type structure. So I can already even envision the three-dimensional structure of this thing just with some simple rules. And so we'll do more of that a bit later, but that's at least one of the Lewis structures from the practice test.